Okay, now that we have this, let's see how we can actually give this some thickness and make this a bit more interesting. For that, we're going to be looking more at this camera for shot 1. So we're going to be having a closer look at the effect. Okay, we could maybe even use a bit more roughness here on the small noise, maybe 0.5, just to break it a bit more. At this distance, this seems better. Yep. Now to give it a bit more thickness, we're going to be using an operator called polywire. Let's have a look at the density of points that we have here. Right now we have a good amount of density. This was useful for us to be able to distort with this amount of detail. But right now, if we apply a polywire to this, each one of these points is going to be a loop around the mesh that's going to be generated along the line. So this will probably be too much. Let's use a resample again, and we'll just say that the maximum length right now can be 0.025. This will help us reduce the amount of points that we have. So here we had 569 and here we have 312. So, and we don't really notice much of a difference in terms of the expression of the shape of the line. Now let's apply the polywire. The polywire, as you can see, gives it some thickness. It transforms the line into an actual mesh. The divisions, the number of divisions is going to control the type of section that we have. Right now we only have 4. Let's increase this to 6 or something. And we have the wire radius, which is where we're going to be controlling the thickness of this. An interesting thing about this polywire is that it reads an attribute. In case it exists, it reads a width attribute. So what we can do is here on our point pop, we can actually have a ramp that allows us to control that width. And that way we can say that it's kind of thinner here, a bit thicker there. And it's going to be an interesting thing to do as well. So let's go back to our point pop. And we're going to use the curve view as well again to remap a ramp. Let's create another ramp parameter. I'm going to call this width ramp. It's also going to be, we need just a float to determine the thickness. So it's going to be a ramp type spline. We're going to feed it the curve view as well. And now we're going to be able to see how do we actually export an attribute that is not on this list. The way we do that is also through bind. Remember, when we're using a bind to load the curve view attribute, and we can use a bind export to export the attribute that we want, and in this case it's going to be the width, and the width is going to be this. Now this ramp is going to give us values from 0 to 1. So besides having this ramp, we're also going to need to have another parameter that's going to control the maximum width. That way it's not going to be 1, it's going to be whatever we choose. So let's create a new parameter. Let's type parameter, and this parameter is going to be called max width. And this is what we're going to be multiplying. Whatever comes out of the ramp is going to be multiplied by the maximum width, and that way we're going to have a certain amount of width. Now here on the point pop, you'll see that we'll have another section down here, the width ramp. I'm just going to give it some value of here, some variation. Let's create a few points here and there, something like this. And let's give it a maximum width of 0.08, something like that. And we're not seeing anything happen because the polywire is still reading this value that we inputted here. But if we type $width, all caps, as you can see, it now recognizes it. Let me go out a bit more so you can actually see what's happening. Okay, and if we go here to the point pop, okay, now we can clearly see that we have a couple of artifacts here and there, but other than that, it's solely working. And yeah, the maximum thickness is a bit too much. Let me type Shift W so we don't see the wireframe. If we look at this from shot 1, going to be seeing this huge variation. So the maximum is a bit too much. Let's say 0.04. Now, still, this shape is still kind of pretty regular if you think about it. So what we're going to be doing is we're actually going to be displacing the mesh, the points of the mesh themselves. For that, we will probably need to have a bit more points. So after this poly wire, we're going to subdivide the mesh to have a bit more geometry, and then apply a similar technique to what we're using here on the point fob to displace the points of the spline. We're going to use that on the mesh itself. So first we're going to be subdividing. Right click, type subdivide. Okay, as you can see, we now have a lot more points, 4 times more points. You can increase the subdivision level by the depth. It's this depth parameter. And I think we have enough points here. Yeah, let's just choose a frame, something like this. Or maybe here, something like this might be interesting. Yeah, frame 22. And now let's create another point fob. I'm going to say this point fob is going to be called distort line, and this is going to be displace surface. Now here on the display surface, this point fob, we're going to be using something very similar. So the basis of this is going to be still going to be a turbulent noise. Okay, and we're going to feed it the position as before. Each vertex will have, each point of the surface is going to have its own position. And then we're going to be using this to control a certain amount of displacement that's going to happen along the normal of the surface. And we'll need a displace, type displace along normal, and we're going to fit it the position. And this is the noise. This time the turbulent noise is not going to be giving us a vector, a direction for the displacement to happen. The direction for the displacement to happen is going to be the normal of the surface. This turbulent noise is just going to control the amount of displacement that's going to happen. And we have an amount there, so let's fit it in. Here on the turbulent noise, I'm still going to be using the original Perlin noise due to the type of range that we have from -1 to 1. And then displaced position is going to go into the output position. And you can see immediately what happens. Now, on the displacement itself, you have a scale. And this is kind of the multiplier, the same thing as the multiplier that we are using before to control how much distortion would happen. Here on the turbulence noise, we could also expose the amplitude. That will also work. So let's just expose some of these parameters. So I'm going to expose the frequency, offset, amplitude, roughness. Okay, and now I'm also going to hide these ones because we don't really want to see those. So let's go back to editor in parameter interface, select these 2 folders, and let's make them invisible. Apply, accept. And now this is what we have. So we have the frequency, which needs to be much higher. The amplitude is still a bit too much. Sorry, 0.02. Okay, but now we have some nice shape. If you think the ray is still too thick, we can just go back to our distort line. Let's add here and set width, and we can say the maximum width is like 3. Yeah, I think this gives us a nice looking result. .7, and you can even animate it. I don't think it's going to be very noticeable, but let's say Shift F times 0.1, and we add some extra animation there. Okay, I'm gonna keep controlling the intensity here. Might still be a bit too much. 0.1, and if I can even make this a bit thinner, 0.3. See, Okay, we have nice thickness, nice variation, nice animation. Yeah, I think it looks good. Let's keep going.